right. Question number 16. Name the following compound. Iron 2 phosphate. Potassium, oh goodness, are we going to be bisulfate or hydrogen sulfate? Let's find out. Okay, I guessed right. Calcium perchlorate. Ammonium sulfate. Cobalt carbonate. Cobalt 2 carbonate. You see what I did? There we go. Balance the following equation. P4 plus Cl2 gives us PCl3. We have 4 P's on this side, 1 on this side. 2 chlorines over there, 3 over there. So let's make these 6 to begin with. 3 here, 2 here. All right. How are we doing so far? Not good, because this is a 2 now, but not right. If we make this guy 4, now we got 4 or 4. 4 times 3 would be 12. How can I get my chlorines to 12? 2 times 6 is 12. So let's see if we did it right. 1, 6, 4. Ta-da! All right, now we've got covalent compounds. Iodine, tribromide, nitrogen, trifluoride. Notice I'm not putting a mono in there. I feel UOIDE, barium sulfate, calcium nitrite, because it's NO2 instead of NO3. Xenon hexafluoride, sulfur dichloride, sodium iodide, zinc sulfide. Okay. Last one. Choose which of the following compounds are best described as ionic. Ionic is going to be in a metal and a non-metal. Sulfur dichloride, no. Barium sulfate, yes. Barium plus a non-metal sulfate is made of non-metals. Calcium nitrate, yes. Iodine tribromide, no. Zinc sulfide, yes. Sodium iodide, yes. Nitrogen trifluoride, no. Xenon hexafluoride, no. Question 19. Fluoroxyurane is composed of 20.7% carbon, 13.8 oxygen, and 65.5 fluorine. All right, so 20.7%. We're going to use our poem. Percent to mass, mass to percent to mass, mass to moles, divide by small, multiply, tell whole. Okay. So, percent to mass, grams, grams, grams. Grams to moles, 20 divided by 12.01, 13.8 divided by 16.00, 65.5 divided by 19 point, let me think of what it is. Fluorine is 18.99. So 18 20.99. 20.7 divided by 12.01. We get 1.72 moles. .8 divided by 16. 0.8625 moles. 65.5 divided by 18.99. 3.45 moles. Divide by small. So we divide them all by 0.8625. 1.72 divided by 0.8625. 1.99, that'll round to 2. So we got a 2 here, a 1 here, 3.45 divided by 0.8625. So our empirical formula, C2OF4. Okay? Now, it says molecular formula. Remember, the empirical formula is simplified. Molecular formula is going to be the total number of particles, and it tells us the molecular formula has a total mass of 116 grams per mole. So what we have to do is figure out what is the mass of this guy, and then how many times will it go in to 116. We know each carbon is 12.01. We know that the oxygen is 16, and we know that our fluorines are 18.99 times 4 equals 115.98. That's the same thing. So guess what? Our empirical formula and our molecular formula are the same. C2OF4. C2OF4. All right, naphthalene, 93% carbon and has a molar mass of 128.17. What are the empirical formula, molecular formula? Well, first of all, what's the other part of it? It's carbon, but what's the other part? What's it say? It's a hydrocarbon. So the other part is going to be hydrogen. So we've got, I've already forgotten, 93.71 carbon. Carbon 93.71, meaning the hydrogen is the rest of that, which is going to be 6.29. Divide that by 12.01, this by 1.008. 93.71 divided by 12. We get 7.8 moles. 6.29 divided by 1.008. And we get 6.2 divided by the smaller of the two. So that's going to be 7.8 divided by 6.2. 39. Does that work right? 7.8 divided by 6.2. Yeah, okay. I didn't think that was right. 1.25. What do we do when we get to the last step? Multiply until whole. 1.25 is the same as 1 1/4 or 5/4. How can I get rid of that in the denominator? If I multiply both of them by 4, I'll get C5H, 1 times 4 is 4. Let's see if that is right. C5H4. Now, second part of this tells us that the molar mass is 128. 128. C5, 5 times 12 is 60 plus 4. So 64 does not equal 128. But if we multiply it by 2, it does. Therefore, the molecular formula of naphthalene is going to be twice that, C10H8. Look at that. Still got it. 6.8 grams of fluorine combined with 1.9 grams of sulfur to give a pure compound. What's the empirical formula of the product? I am going to hit stop and set it up so you don't have to listen to me do all that, and I'll come right back. All right, so I put in 6.84 grams of fluorine divided by, or added to 1.93 grams of sulfur to give a pure compound. The empirical formula is going to be F6S. Now, I will tell you, we've got to reverse those. Fluorine, being the most electronegative, is going to be written last. Sulfur will be written first. So we'll go SF6. Da-da-da-da. Next question, we're balancing again. 1 iron, 1 iron, 2 chlorines, 3 chlorines. So I'm going to put a 3 here, I'm going to put a 2 here. Now I've got 6 chlorines on both sides, and I need 2 irons over here. Tin oxide plus carbon gives us tin and carbon monoxide. We've got 2 oxygens in the tin and only 1 here, so we'll need a 2. We need 2 carbons since we have 2 here now. There we go. Solubility rules. Hydroxides are almost always insoluble with the exception of the alkali metals and the big 3 hydroxide. No. Yes, the big 3 hydroxides. So he's going to be insoluble. Bromines are usually going to be soluble. Halides are. Carbonates are usually insoluble. So which are going to be soluble? Only the bromine. I shouldn't have clicked them all. Decide if the following is water soluble or not. Nickel chloride, almost all the nickels are, or all the chlorines are. Barium bromide, again, bromine, the halides are going to be soluble. Sulfates are usually soluble except for the big 3 in alkali earth. So barium sulfate will not be soluble. Barium sulfate, we just said was not going to be soluble. Copper 2-phosphate. Phosphates are never soluble. Barium bromide. Bromides are usually going to be soluble. Question has multiple parts. The following compound is water soluble. What ions are produced in aqueous solution? The cation is going to be iron. Fe, and it's going to be 2 plus because he's a plus 2. I guess those guys should go up. Will they not? and there'll be one of them. Chlorine will have two of them. There we go. We're going to have two NH4s, and we're going to have one sulfide. And that should be up. What did I do wrong? Oh, I didn't put the plus sign on it. Duh. All right. 26. Choose the most accurate definition for an electrolyte. Electrolytes dissolve in water and conduct electricity. So they are aqueous solutions who conduct electricity. True. Electrolytes are all substances that conduct electricity. False. They have to be aqueous. All liquids. False. They have to be dissolved. Ionic compounds that are soluble in water. I'm going to go with the first one. There we go. You can differentiate experimentally between a weak electrolyte and a strong electrolyte by measuring electrical conductivity. Which of the following is true? The conductivity of the strong electrolyte is higher than that of the weak. True. Some examples of electrolytes are listed here, which are strong. A strong electrolyte is going to be something that dissociates completely. Sodium chloride is going to dissociate completely. The reason the hydrogen and the hydroiodic acid and the phosphoric acid don't is because they're weak acids. Partially correct. HI is a strong acid, therefore it would have dissociated. Obviously, I'm getting tired. Net ionic equation. Where am I writing it at? Next part. First, write out each species as it exists in solution. Which, if either of the reactants exist as separate ions in solution? They both do. They're both going to separate into ions. The next step is to identify any acids or bases. Do we have an acid present? No, there's no H. The next step is to see if an insoluble product can form from the ions that are available. If silver combines with carbonate, will it precipitate? Because potassium and nitrate, we know, will not. Well, carbonates usually are precipitable. So let's see what it says here. Most salts of carbonate, the exceptions are right here. It doesn't list silver as an exception, although I think in lab it was slightly soluble. This is a precipitation reaction. Are any of these guys spectator ions? Why, yes. Potassium and nitrate are, because they are just watching. Alrighty, the final step is to balance. I have one silver, but I need two, so this guy is not balanced. I have one carbonate, I have one carbonate. Alright, balance the reaction of strontium hydroxide and calcium chloride to give calcium hydroxide and strontium chloride. Strontium hydroxide, all of those strontium hydroxides are written correctly, all the calciums are. Calcium hydroxide and strontium chloride. We need two hydroxides, two hydroxides, two chlorines, two chlorines. Do we need the twos there? No. Two hydroxides, two hydroxides, two chlorines, two chlorines. I'm going to go with that guy. We've got two hydroxides here, two hydroxides here, two chlorines, two chlorines. What's the correct net ionic equation for the reaction? That means what's going to be soluble. Hydroxides are usually soluble. So this calcium hydroxide is going to, or insoluble. Calcium hydroxide is going to form a precipitate. Strontium chloride is going to be what's left. They're spectator ions. They cancel out. So we're going to have calcium ions plus two hydroxides give us calcium oxide.